Thank you for inviting me to present. This is joint with Mike Sposey and Jing Zhang. And I think Mike and Jing are here to answer any questions in the chat, or they will be here shortly. And Jing and I have affiliations with the Federal Reserve System, so the views expressed here are our own and not those of the Fed system. So I'm going to start by showing some motivating facts about structural change. And the first fact is a very well-known fact that as countries develop, the value-added share of agriculture, or to be a little more precise, the share of agriculture in total value-added or total GDP declines. The share of services rises, and then in manufacturing, the share rises and then falls, or it follows a hump pattern. And this is true, by the way, not just for value-added shares, but also employment shares. So you can see this pattern in the pictures that I show below. On the x-axis is per capita income in PPP terms relative to the United States in 2011. And you can see it's a log scale. And then the y-axis is the sectoral value-added shares. And you can see the patterns that I just described. So this is a well-known, maybe the most well-known fact of structural change. But what's less well-known is whether and how this relationship has changed over time. So to look at how it's changed over time, we run the following regression. On the left-hand side, we have the value-added share, the sector value-added share. So we run this regression, by the way, for each sector separately. So the left-hand side, for example, for agriculture is this sector, the value-added share in agriculture. And again, by value-added share, I mean agriculture's share of total value-added in the economy. For our country sample and for all the years that we have, and we run that on country fixed effects. And then we have these per capita income variables, the log of per capita income and the log of per capita income squared. And we allow for the coefficients to change, these betas, we allow them to change according to whether the time period is before 1990 or after 1990. And we pick 1990 because it's roughly halfway through our sample, which runs from 1970 to 2011. So we estimate this regression for each sector separately. And then with the estimated coefficients, we take the average country fixed effect, and then we just plot out as income varies, you know, like going from left to right on each of these diagrams, we just plot out the pattern, the implied value-added share, sector value-added share as income increases. And so that's what we see in these three panels. And in each of the panels, the darker line represents the coefficients prior to 1990, or the implications from the coefficients prior to 1990, and the lighter line represents the implications of the coefficients after 1990. And I'm just going to focus on the middle panel for manufacturing. And you can see this pattern that the peak of this manufacturing hump declines between pre-1990 and post-1990. And it declines by about 3.5 percentage points. So this has been called deindustrialization by, most notably by Danny Roderick in a paper he wrote about 5 years ago. So basically, the later industrializers now are not achieving as much manufacturing intensity as countries that industrialized earlier. That's basically what this pattern shows. I should add that you should feel free to ask questions at any time.
Kei-Mu, sorry.
Sure.
Can I ask a question now?
Sure, yes.
So the message of this graph is that countries that experience structural transformation later on are relocating from manufacturing to service in a faster pace now, no? This is what you are saying now?
Yeah, so another way of interpreting what's going on is exactly what you said, that, as you can see on the left, factors are obviously still leaving agriculture very rapidly. And what's different between pre-1990 and post-1990 is they're, in the post-90 period, they're going into services more rapidly than, say, manufacturing.
Okay, that's something that is, I get curious here, is that I also would expect that countries that peak later would have peaked at a lower per capita income at the moment of the peak than those ones than the countries that peaks earlier. No? But from this graph, it seems that the peak in manufacturing is happening at the same level of development.
Yeah, it's hard to see, but it is at a little bit lower. It is at a little bit lower per capita income. So I should say parenthetically that in Roderick's paper, he also pointed to this fact you just mentioned. We don't see it as much with the value-added data, although with the employment data, we've kind of run similar regressions with employment data, and you see it a little bit more. But partly because it was a little bit less robust, we're just focusing more on this decline, you know, and not associating it with lower per capita income at the peak.
Thanks.
Bernabe, did you have a question?
No, just to tell you that Michael and Jing are panelists already.
Okay, great, thank you. So, yeah, as I alluded to, this fact, as to our knowledge, was first pointed out by Roderick, and so what we've done is just, in a sense, replicated that fact with a slightly different data set and time period. And we're going to call this the same thing he did, deindustrialization. So now I want to show a second kind of relatively new fact, and to our knowledge, it hasn't been documented before. And this is on the variance, like the second moment of these sectoral value-added shares. So in this table, we have two sets of numbers. The left set is the unconditional variance, and the right set is the conditional variance. So looking at the left set first, the unconditional variance, all we've done is just take the raw data on these value-added shares. And so for all the pre-1990 years and for all the countries, we just computed the variance. And for agriculture, it's like 64%. And we do that for pre-1990 and then also post-1990. And then you look at the change, and the pattern that jumps out is in agriculture, it barely changed, it barely increased. In services, it actually declined substantially. And then in manufacturing, it increased substantially. So basically in manufacturing, just in the raw data, if you compare pre-1990 to post-1990, the dispersion in the value-added shares across countries and for these years in the particular time periods, it increased between pre-90 and post-90. That's the raw data. Then what we call the conditional variance, the data are the residuals from the regression here. So basically these epsilons. So we've sort of filtered out the country fixed effects and then the effects of the log per capita income and log per capita income squared. And because we're looking at residuals, of course, these numbers overall are smaller than with the unconditional numbers. But if you compare pre-1990 to post-1990, you see a similar pattern. In agriculture and services, actually, this conditional variance declined, but in manufacturing, it increased. So kind of the main takeaway is whether you look at the raw data or this conditioned data, the cross-country dispersion in the manufacturing value-added shares has increased over time, and specifically between the pre-1990 and post-1990 time periods. So we're going to call this industry polarization. There's just greater dispersion in these manufacturing value-added shares across countries. So kind of the main goal of our paper is to try to explain these two patterns. What are the drivers of deindustrialization and industry polarization over time? And so, of course, we are interested in this as an academic question, but it's also important in policy discussions, both historically and in the present. And of course, as you know, historically, It was industrialization that separated countries into rich countries and not so rich countries for the most part. And then even today, policymakers continue to believe that manufacturing is a driver of growth, partly because manufacturing tends to have high TFP growth, total factor productivity growth, because there's some evidence out there that there are spillovers to other sectors. The less skilled workers tend to have higher returns in those sectors. And many countries have industrial policies to increase or rebuild up the manufacturing sector. So, so this is another motivation for what we're doing. And, you know, there are many possible drivers, and we're just going to focus on two: trade integration over time, broadly speaking, globalization, and then also sector bias productivity growth or asymmetric productivity growth across sectors. So how are we going to do this? We're going to take a quantitative theory approach. We're going to build and calibrate a dynamic trade model of structural change, where the main drivers, as I mentioned, are shocks to sectoral productivity growth and also to trade costs, which are going to be declining over time. And these drivers are going to be mediated through our model, and the mechanisms in the model are going to be income effects, relative price and substitution effects, and then also a comparative advantage. And so when we calibrate our model, we're going to find that we can get, with just those two drivers, we can match 2/3 of the deindustrialization and all of the industry polarization. And then it's also going to be consistent not only with the value added shares, but also the spending, the final demand spending shares and intermediate spending shares, both at the sector level and the aggregate level. Then we're going to take our calibrated model and run some counterfactuals, 3 in particular, basically to see the roles of the separate roles of trade integration and also sector bias productivity growth and the channels by which they're operating, and which one is more important for each of those two facts, for deindustrialization and industry polarization. And so in particular, we're going to run 3 counterfactuals. So in one of them, we shut down trade integration. So the only driving force is going to be the sector bias productivity growth. In the next one, we shut down the sector bias productivity growth. So the only driving force is trade integration. And then in the third one, we shut down both driving forces. So I'll describe these counterfactuals in more detail a little later. So let me briefly
Can I ask you something?
Sure.
Can your polarization data is you're thinking about the conditional or conditional variance of your data? Because the conditional variance is look very small, the change, no?
Yeah.
It's really
So it looks small, but it's relative to a small base. You know, as I mentioned, these are coming from the residuals of the regression. These are coming from these epsilons here. So, so the variance themselves are very small. And so, so what we've reported here is like the absolute change, just the difference. I mean, perhaps a slightly better way to think about it is the percent change, so percent of percent. And there, I think the main pattern is that, you know, in agriculture and services, the variance, this conditional variance declined substantially, but in manufacturing it increased. When we report the outcomes of our model, we'll show both sets of numbers. We'll show the unconditional variance coming out of our model, and then we'll also run that same regression with our model generated data, and we'll generate these conditional variance numbers too. So you can do these, you know, apples to apples comparisons.
Okay, thank you.
Kei-Mu, can I ask you a question?
Yes.
This is Federico.
Hi, Federico.
Hey, so kind of a more broad question is, so this motivation from Roderick is kind of thinking about these sort of externalities of manufacturing sector, right? But could it be that also in the last 20 years that has been changing in the sense that services now are more sophisticated than before, are more sort of technological intensive, and maybe also that is changing over time? To what extent services is also creating spillovers to the rest of the economy, and therefore maybe deindustrialization is less of a concern today than what it was in the past, where services were more basic and less sophisticated?
Yeah, thank you. That is a possible story. The only thing is in the data that we're looking at, and ultimately we're going to have a story at the end. And a key part of that story is that TFP growth in manufacturing is higher than in services. So the relative price of manufacturing to services is falling over time. And that's going to be driving a lot of the action between pre-1990 and post-1990. You know, I should say that our services are pretty broad. So it's possible that what you're saying is correct for some services sectors, but maybe it's not showing up in the aggregate, you know, the aggregate services composite that we have.
Right. So in that sense, are you thinking about opening up services? Because, you know, you can have like retail that might be sort of less sophisticated, and then other services that are more sophisticated, like technological services.
Yeah. So we're going to calibrate all the trade costs to match the bilateral trade flows, and you're going to see that the services trade costs are declining over time. However, they're not declining as rapidly as in manufacturing. So I think a better way to address your question is to maybe expand our broad three sectors and have, you know, like maybe two services sectors. One more traditional services and one more modern services, where the modern services might look like manufacturing in terms of the productivity growth and the trade cost declines. But we haven't done that here. And I think these effects that you're talking about are sort of washed out in our broad services aggregate.
Right. Yeah, thanks. I'm thinking about like this categorization of services of you know, Connor Walsh, Philip Eckert's, and Shelley Ganapati's work of like skilled tradable services that are driving inequality in the US and divergence across regions. And those are really technologically intensive. So you might think that those have spillovers that could be maybe stronger even than some manufacturing sectors.
Yeah, I agree. I agree that those, as you said, the papers that you mentioned have documented their importance, and so so that's obviously an avenue for future work for us. Thank you.
Thanks.
So let me just briefly, this is a very small literature review, and as I said, we were mainly inspired by the paper by Roderick 5 years ago. And then Mike, Jing, and I separately and together have worked on open economy models of structural change. And we're also linked to papers that point to the importance of input-output linkages and also investment and structural change. And then finally, we're going to have this dynamic model where the dynamics are coming from capital accumulation. Okay, so in the remainder of the talk, I'm going to lay out the model and then show some of the key equations and describe some of the intuition, and then I'll turn to the calibration and some of the calibration results, and then finally the counterfactual exercises. So I'm going to turn to the model now, and first just a brief overview. So as I mentioned, it's a multi-country, three-sector dynamic model, and the source of trade is going to be Ricardian comparative advantage. So it's going to be based on relative productivity differences across countries and goods. And then just some notation, time is going to be indexed by little t, countries by little n, and then the sectors by little j. And as I alluded to, we're going to have three sectors: agriculture, manufacturing, and services. And then within each sector, there are going to be a continuum of potentially tradable varieties. And as is common in the classic neoclassical trade models, each country has the technologies for making all varieties in all sectors. And it's going to be comparative advantage along with trade costs that determines which country makes which share of which varieties in a sector for sale to another country. And then there's going to be some aggregation. I'll get into that in a little more detail, where these individual varieties get aggregated to sectoral composites, and then they get aggregated to a national composite good. And then finally, the macro side, we have a representative household in each country that's going to choose consumption and investment paths to maximize a infinite horizon utility function. And then last, we have perfect foresight, and this is going to be a perfect competition model. So that's the overview. Let me get into some of the equations, starting with the representative household, the preference side. So the representative household is maximizing this lifetime utility function of per capita consumption. And we're going to have this preference shifter Xi, which is going to help us match in aggregate investment rates. So it's a national kind of preference shifter, as I said, to help match aggregate investment. But the main part of our utility function involves this capital C, which is the composite consumption good. And that composite consumption good is an aggregate of the sector level consumption goods given by this little c nt with the superscript j. That's the sector level composite consumption good. And we're using this non-homothetic CES function, which has been popularized recently by Comín, Lashkari, and Mestieri. And the main reason why we're doing this is the more common non-homothetic utility function is the Stone-Geary preferences. But the Stone-Geary preferences with the subsistence consumption basically imply that as countries become rich, in the limit, preferences become homothetic again, in which income elasticities are all unitary. But there's a lot of evidence in advanced countries that preferences continue to be non-homothetic, with income elasticities deviating from 1, even as I said, in rich countries. So that's why CLM, Comín, Lashkari, Mestieri, introduced or reintroduced these preferences, which were first developed in the 1960s. The key part of these preferences are these epsilons, which are utility elasticities, although I'm going to call them income elasticities, and they can deviate from 1, and we're going to have the usual formulation where the agriculture elasticity, income elasticity will be less than 1, and the services income elasticity will be greater than 1. And then the other parameter I want to mention is this sigma c. That's the usual elasticity of substitution across the sectoral consumption goods. And when we calibrate it later, that elasticity is going to be less than 1. So the sectoral goods are going to be complements in the overall consumption bundle. So these are the preferences. The budget.
Sorry.
Yes.
A short question, I didn't understand. So the epsilons, that's a result or that's an assumption? The ordering of the size of the income elasticity?
No, it's going to be a result. We're going to estimate them. Okay. In fact, my co-authors, Mike and Jing, estimated them in a different paper, and we're going to use them. And they're currently we are currently re-estimating them in a setting more specific to our paper, but we don't have the results yet. But they're basically a result. These numbers here.
Okay.
Sorry, but you need to normalize 1, so it's gonna.
We need to normalize 1, and so we're normalizing the manufacturing 1 to be 1. Exactly. Okay. So here is the budget constraint. It's basically spending on the left-hand side equals income on the right-hand side. You'll see that the consumption composite and the investment composite have their own price levels, and it's because they're aggregated in different ways. The only other thing I want to mention is we do allow for trade imbalances, but we take this shortcut that many people, including Caliendo et al., have used. And the idea of the shortcut is all the countries' trade surpluses, for example, get pooled into like this mutual fund. And then at the end of the year, the proceeds from that mutual fund are dispersed in equal amounts to every per capita person, in the world. And so that's it's kind of it's endogenous trade balances, but in the most exogenous way possible, I guess is one way to say that. And the fee is going to be, that's going to be this time varying parameter that allows us to match the trade imbalances over time. The last thing I want to mention in terms of the macro setup is the capital accumulation. And here we allow for a little bit of adjustment cost through this lambda parameter. If lambda equals 1, then it's the usual capital accumulation equation. If lambda is less than 1, then capital accumulation is a little bit sticky. If lambda is 0, then it's 100% sticky. And we're going to take this parameter from another recent paper. And this investment composite good is made up of, it's a CES function of the sector level investment goods. And you can see that this is different. This is a regular CES function as opposed to a non-homothetic CES that we had for the consumption composite. And then we have this elasticity of substitution, sigma x. So that's the macro setup. But before going to the production side, I want to show some implications for the spending shares and then just show the Euler equation. So these are this top equation is the sectoral consumption spending shares. So the left-hand side is like the spending on sector J, consumption goods relative to total consumption spending. And you see 3 terms. Omega is like the Armington preference weight. And then the second term is a relative price term. And then the third term comes because of the non-homothetic preferences. To the extent epsilon j, the utility elasticity differs from 1, then it is relevant. And so in the case of services where epsilon j is greater than 1, and as I alluded to before, the sigma c is going to be less than 1, then this is a positive exponent. So as countries get richer, then the share of spending on services is going to increase. So that's how the non-homothetic preferences come in on the sectoral consumption shares. The second equation is on the sectoral investment shares. This is a regular CES function, so there is no income term, and it just depends on relative prices, like in the usual CES way, and then of course the Armington weight. And then the final equation is the Euler equation, linking per capita income growth, and there are 3 to the kind of the return to saving, and then there are 3 terms on the right-hand side, and the first term are these is this preference shifter term, or the change in the preference shifters over time. And so you can see how that's going to affect investment rates. The second term is kind of the main Euler equation term, but because we have the adjustment costs, it's a little bit more complicated. And then finally, we have these relative price terms. And to the extent these relative prices are changing over time, the relative price of the investment good to the consumption good, to the extent they're changing over time, that affects the, the effective interest rate, which of course will affect the consumption paths.
Okay, can I ask you something?
Yes.
So here in the setup, you don't have investment specific technical change, no? So the difference in the price of investment goods and consumption goods are just coming from the different composition between.
Yes, that's right.
Sectoral composition between investment and consumption.
That's right. That's right. In fact, I'm about to get into that, but that's exactly right. We don't have investment-specific technical change. So, as you said, all the movements in these relative prices of the investment to the consumption good is in the aggregation. So let's turn to the production side now, and where I can amplify on your point. So this is the production function for an individual variety in like sector J. And you can see it's Cobb-Douglas in value added, and then this composite intermediate, which I'll define in more detail in a second. And then within value added, in itself is Cobb-Douglas in capital and labor. One thing I want to point out is you see the coefficient on capital is alpha, and it's the same across sectors, countries, and time. And that is to preserve the Ricardian trade only feature of our model. If we had alpha vary across sectors, for example, we would also have a Hechter-Lin setting. So this, as I mentioned, is just a purely Ricardian trade model. Actually, one thing I'll say about this intermediate composite, that's going to be a CES function as well. So this is not a pure nested Cobb-Douglas. It's kind of this blended nested Cobb-Douglas and CES. The other thing I want to mention with this production function is the productivity terms. We have two. So the capital A is, you can think of as the usual TFP term that varies across sectors and countries and is time varying. And then the little a, this is going to be also a productivity term that will vary across the varieties. And this is going to be the distributed as a Frechet with a variance parameter governed by this theta. And this is the distribution, that Eaton and Korda made famous. So, and I'll show one of the implications of this on the next slide. So we have these two productivity terms. So that's the production function for an individual variety. And then it's these varieties that are traded across countries. And then, you can think of these aggregator firms that aggregate these varieties to make a sectoral composite good, this QJNT, that's a sectoral composite good. And then that sectoral composite good goes to be a consumption composite, an investment composite, and then this intermediate input composite. But then, as I mentioned before, and then also in response to Luciano's question, the way that these sectoral goods are aggregated to make the aggregate consumption good, the aggregate investment good, and the aggregate intermediate, they vary, and that's why they're going to have their own price indices.
Kei-Mu, what?
Yes.
Why would it be an issue? This is Federico again. Why would it be an issue for having the Heckscher-Lean forces? Why I missed it.
No, I mean, we could. In fact, Mike Jing and I have a related paper with Heckscher-Lean forces running around. It's just that we chose not to do this so far here.
Okay.
Thanks. I mean, so this is another possible extension.
Mm-hmm.
So we're going to have trade costs in kind of the usual way with just these iceberg costs. So if one unit is going to be received by country N from country I, then D units greater than one have to be shipped. And the only time where the Ds are equal to one is where it's a within country trade. So thanks to that Frechet distribution, you have this pi equation that's next, and the pi equation governs spending shares or import shares of absorption. So specifically on the left-hand side, we have for sector J, the share of spending by country N on goods from country I in period T. And it has this familiar form that comes from like the industrial organization literature. Eaton and Korda call this numerator a competitiveness term. You can see it's positively related to country I's total factor productivity. Little u is the cost of a bundle of inputs of capital, labor, and the intermediate input. And then D is this trade cost linking countries N and I. And so obviously it's negatively related to the cost of the inputs and then the trade cost. And the denominator is actually closely related to the sector level price index. It's proportional to the sector level price index. And you can see that in any country N, that price index basically depends on the productivities and factor costs and the trade costs of all the other countries in the world. In some sense, it's a weighted average of the productivities and factor costs of all the other countries in the world, where the weights are like the inverse trade costs. So this will matter for interpreting some of our results later. So that's it for the equations of the model. This is just the statement of the equilibrium. So now I'm going to turn to the calibration and then the counterfactual exercises. So here's our set of countries. We have 28 countries plus the rest of the world. Unfortunately, Chile is not here, largely because the World Input-Output Database doesn't have input-output tables for Chile, but they're implicitly a part of the rest of the world. Chile is implicitly a part of the rest of the world here. And we have three broad sectors: agriculture, manufacturing, and services. And one thing I should clarify is when I say manufacturing, I really mean industry, which is manufacturing plus mining, electricity, and water. And as you know, in Chile's case, it makes a huge difference because of the big importance of mining in the recent decade and a half. So, but yeah, when I say manufacturing, I really mean these four sectors: mining, manufacturing, electricity, and water. And then services are the remaining sectors, and it's still a very broad set of categories in services. So let me turn, so that's our countries and sectors. Let me turn to the parameters. There are a bunch of them. And so what we've done is just separate them into time invariant parameters, and then we've got these time varying parameters and exogenous variables. And these income elasticities that we talked about earlier, right now they come from a separate paper that Mike and Jing have. And you can see that the agriculture elasticity is very low, and then the services income elasticity is greater than 1. And then we have all the substitution elasticities coming partly from Mike and Jing's separate work, and then also other papers. And really the bottom line from all of these elasticities is they're less than 1. So whether it's the consumption composite, the investment composite, or these intermediate input composites, they're all the sectoral goods that make up those composites, they're all complements. And that's going to be important. And partly because they're complements, we just call them the Baumol elasticities. Then among these more macro parameters, the only one I'll highlight is the lambda, that capital adjustment cost elasticity. And there we just take it from a recent paper by Eaton, Korda, Neiman, and Ramalis, and it's set to 3/4. So remember, 1 is where capital adjusts fully, or in the usual capital accumulation equation. And then 0 is capital is fully sticky. So we're like 3/4 flexible in some sense. And then our trade elasticity is from Simonowska and Waugh, and we set that to 4. At the bottom here, there's a lot of, there's the value added to gross output ratios, and then these Armington weights. And in principle, these could be time varying. But to make interpreting the results of our model simpler, we hold these all fixed at the average over time for each country and sector. And that's for the value added to gross output ratio. For these Armington weights, we actually fixed them at whatever they were in 1995. And when we take these value added to gross output ratios and then average those averages across countries, this is what we get. And you see the usual thing where in the manufacturing or industrial sector, that has the lowest value added to gross output ratio, or in other words, the most intermediate goods. So those are the time invariant parameters, and then the time varying parameters or exogenous variables. There are 5 of them, but we highlight in blue the TFP and the trade cost because those are going to be sector specific. The other 3, the preference shifters, that aggregate imbalance shifter, and aggregate labor, these are all national variables, and they're set so that the model can replicate aggregate investment rates, trade imbalances, and employment. But again, going to the top rows again, the sector level TFP and the sector level bilateral trade costs, they're going to be calibrated so that the model can match sector level prices and sector level bilateral trade flows as closely as possible. So
may I ask you something?
Yes.
It's about you're assuming that the elasticity of substitution of service and factoring goods are the same, the trade elasticities, or not? That's the omega j is 4 for all of them?
The trade elasticities are governed by these thetas. Yeah, the thetas, and it is the same for all goods.
And do you have some idea about whether there's some difference in trade in services? Elasticity is different from.
Yes, there could be. I mean, I would not be surprised if there was. I mean, one thing I can mention is I have another paper where we actually estimate these trade elasticities using the Simonovsky and Waugh method, but they're all among different manufacturing subsectors. And the range is large, from like 1 to 15, something like that. And Caliendo and Paro, of course, have their NAFTA paper estimated the manufacturing trade elasticities, and they also have a wide range. So given that wide range within manufacturing subsectors, I would not be surprised if there was a difference between the trade elasticity for manufacturing overall versus for services overall. But we have not done that. So that again is a possible extension to allow for that variation. All right, so now I'm going to show the sector level trade costs and the sector level productivities that we calibrate, to match these sector level prices and bilateral trade flows as much as possible. So that's shown in these 6 pictures here, where the top 3 are the trade costs and the bottom 3 are the TFP terms. So in each of the, let's start with the trade costs. In each of these pictures, the heavy line in the middle is the median across countries for each year. And then the other 2 lines are like the interquartile range across the countries in our sample. So the main takeaway from this, the top 3 pictures, is you can see that trade costs are, well, they're all pretty high. Like, for example, 8 means roughly a 700% trade cost. They're all high, but they're all declining over time. It's a little hard to see, but the manufacturing trade costs and the agriculture trade costs are declining more rapidly than the services trade costs. So again, I just want to highlight, if we just compare manufacturing and services, the manufacturing trade costs are declining more rapidly than the services trade costs. Then if we look at the bottom panel on productivity, here we've done this normalization where they're all set equal to 1. The median value is set equal to 1 in 1971. So these pictures are really pictures of productivity growth over time. And again, you see that productivity growth in manufacturing and agriculture exceeds that in services. And I'll be coming back to this later. So this is the calibrated trade costs and productivity coming out of our model. And again, those trade costs and productivities were calibrated to match data on bilateral trade shares and sectoral prices. So because those those trade costs and productivities were calibrated to match these variables, you would expect the fit to be pretty tight, and it is pretty tight. Where the model is on the horizontal, the data is on the horizontal axis and the model is on the vertical axis, and the black line is the 45-degree line. And then all of the points in green, blue, and red are the model the combination of the data and the model implication. And so you see it's a pretty tight fit. But what about for the sectoral value? Is there a question?
May I ask something about, can you talk a little about the identification of between the productivity shocks at the sectoral level and the trade costs? Because in some sense they will tend to be, if you have a large falls in the trade costs, it's like a productivity shock for the others. Not, or are confusing?
No, that's right. That's right. The trade costs, they are a little, as you said, the trade costs act like a productivity shock for the other countries. And so in that sense, there is a little bit of an overlap. It's just that the way that, and going on the other side, changes in productivity are going to affect trade patterns implicitly, because changes in productivity, all else equal, affect comparative advantage, which then affects trade patterns. But that said, it is still the case that these bilateral trade costs, first order affect the trade flows, more than productivity does, and vice versa.
Yeah, but I understand the idea that the trade costs affect the productivity of others, not yours. But when you do a round, they start to affect you again, no? So it's very difficult to identify, no?
That's right. And I mean, again, we're not identifying this in this econometric sense, right? We're kind
I
of,
understand, but you calibrate.
yeah, right. This is a calibration. And well, I think the sense in which the point you made makes it a little bit challenging is this is the fact that these things are not perfect fits. If it was easy to do this calibration across all these country sectors and time periods, it would be a perfect fit. Because we have like n equations and n unknowns. So and you can see it's not exactly perfect. So there is a little bit of challenge there, and I think part of that challenge is from this point that you're making.
Okay.
So now I want to show kind of a non-targeted moment or non-targeted outcome, and one that we care about, the sectoral value-added shares. And here we have, again, the data on the x-axis and the model on the y-axis, and the black line is the 45-degree line. And you can see the fit is not as good as on the previous charts, but it's still a pretty good fit that when the data has a higher, when some country in some year has a higher manufacturing value-added share in the data, it's also pretty much implied by the model too. And then last, we don't show this here, we'll show it later. With all the model implied results, for these value-added shares, we run the same regression that we ran in the data, because our model was calibrated to the same set of countries and time periods as in that actual regression we ran on the data. So we run that same regression with our model generated data that we ran on the actual data, and you get that same hump pattern and the decline in the hump pattern between the pre-1990 and post-1990 period. And we can't get all of the decline, but basically 2/3 of the declines. Instead of 3.4 percentage points, we get like 2.2 percentage points of that decline. Okay.
Okay. Can I ask?
Yes.
I have one curiosity. So if I understand it correctly here, so this difference that we see, for instance, in the hand shaping manufacturing, that pre and post 90 period, what you're saying is that is trade that is in a way exacerbating the income and the substitution effect, and for some reason now there are less barriers and now it's easy to trade, and this is generating this difference in the. I am not. Is that correct, or I am missing something?
Well, so what we can say right now so far is that the trade integration and the sector biased productivity growth taken together can account for this 2/3 of the decline we see in the data. But now I want to do some counterfactual exercises to try to tease out in more detail what exactly is going on, which driving force is more important and why. Okay, so that will really, so what I'll show in the next few minutes, I think will address your question in more detail.
Okay, and given that, so it is fair to say that if you do that as a similar analysis, cutting your sample in pre and post 90s, and look at the movements of prices, because everything seems going through prices, do we find more movements across prices faced by different countries in this in the post 19 than the pre 19? So I'm thinking that now that there are more trade and everything is more integrated, sectoral prices faced by countries can move more now than before.
That's a very good question. I don't know the answer off the top of my head, but that is something we should look at. Yeah. One thing I can say is, as trade costs come down, this is not a co-movement point. This is more a first moment point. But as trade costs come down, just the variance of these sector prices across countries, just the prices themselves should be less because the world is just becoming more integrated. Okay.
One short question. I might have missed this, but I thought that with the flexibility that you have on the trade cost and the productivity, you can basically sort of replicate the data fairly well. Why can you not account? Why can the model not account for the full decline in manufacturing peaks?
Because it goes back to how we calibrated the model. We all these value added to gross output ratios, and then these Armington weights, we held them constant. If we made all of these time varying, then we could match the data more closely. In fact, we had an earlier version of the paper. It was more a wedge analysis paper where we had 7 shocks running around. And but it was very hard, so we could fit the data better, but it was really hard to get intuition from there. So we decided to scale back and make it simpler and just focus on those 2 main sets of shocks at the cost of a not as good of a fit.
So Kei-Mu, this is Jing. So can I just add?
Oh yeah, hi Jing.
Yeah.
Jing is one of our co-authors.
So
Hey.
Federico, so
Yeah.
one reason we cannot get a perfect match is, we limit also the trade cost across country to be about 1. So sometimes, the noisy of the data or mismeasurement require the trade cost less than 1 across border, and we have to put that constraint. So basically the nonlinear constraint we have to put in. So we cannot get the perfect match. That's one reason. Another one is a sigma, right? So if you allow us to allow all this input usage or investment demand usage to be, exactly like say Douglas, take the share from the data, then we can do almost perfect matching there. But here we limited ourselves to the CS formulation, right? So there will be also errors from that side too. Yeah. So for value added, you have both consumption and all this input usage, right? So we did a very good job in consumption, but for some inputs, we have to give it up, given the, I would say, parsimonious specification of the production function. Yeah.
Okay, thanks.
How about the help? Yeah.
Thank you. So now I want to get at this question of, which of the 2 driving forces is responsible for deindustrialization and which one for industry polarization and why. And to do that, we've got these 3 counterfactual exercises. So one of them, which we call Autarky Counterfactual, it basically sets the trade costs prohibitively high. So in other words, in this counterfactual, the only driving force is the sector bias productivity growth. Then in a second counterfactual, we flip it, and so we remove the sector bias in productivity growth. So it's what we call constant relative productivity, and each sector basically grows at the aggregate productivity growth rate. So here, the main driving force is just trade integration. And then in the final counterfactual, we shut down both trade integration and the sector bias in productivity growth. Those are the 3 counterfactuals. And so now I'm going to show what they imply, first for the deindustrialization and then for the industry polarization.
May I ask you something about I'm a little confused. In all your counterfactual models, you have an increase in income per capita.
That's right. In all the counterfactual models, per capita income is increasing because we have this productivity growth growing.
Yeah, and my question is how much is the question about how much the utility function is affecting the composition only by the fact of increasing GDP per capita. Because in some sense you have you will increase more services relative to manufacturing, and that will push to close the gap, no? By consumption.
That's right. Because of the non-homothetic preferences, when there's income growth, and then also because of the services income elasticity, that alone is going to cause structural change shifting towards services. So
it's not be better to try to get rid of this effect and to have the income become constant in both exercise, because otherwise you will have this effect now.
Yeah, we could get rid of the income effect in two ways. We could do it the way you suggested, hold income constant, or the other way would just be to remove the non-homothetic mechanism and just do homothetic preferences. And so that again is an exercise for the future, or that we have not done so far. But as it turns out, I'm going to argue in the next few minutes, in the conclusion of the next few minutes, that these non-homothetic forces are not that big. These relative price forces are going to be the dominant force. So, yeah, so this, yes?
This is Mike. Could I elaborate on your answer?
Yeah, sure.
So yeah, to Alejandro's question. Yeah, Alejandro, you're right. So the income effects are contributing to the structural change. So this CRP, or constant relative productivity counterfactual, is designed so that we generate the same path for income. So we're keeping the income effect the same in the baseline as in the counterfactual. The only difference between the two is, the relative price force is going to be operating. So it's just a way for us to isolate the contribution from differential productivity growth to the extent that it, affects relative prices and shapes structural change. So we're just isolating that one particular channel, keeping income effects equal across both scenarios.
Thank you. Understand.
Thanks, Mike. So here are the model implied value added shares for each of the three scenarios. And I'm going to focus on the middle column, which is manufacturing. And then the solid lines, you'll see each of the pictures has solid lines and dashed lines. So the solid lines are from the baseline model with both driving forces, the trade integration and the sector bias productivity growth. And then the dashed lines are the outcomes from the particular counterfactual, where again, the solid dashed line is for the pre-1990 period. I'm sorry, the darker dashed line is from the pre-1990 period, and the lighter dashed line is for the post-1990 period. So let me start with the scenario A, which is where we shut down both trade integration and the sector biased productivity growth. So here all we have is just like aggregate productivity growth. And you can see two things. First of all, there's not much of a pump pattern at all. And then more to the question of deindustrialization, you see virtually no change between pre-1990 and post-1990. So this is just another way of saying that our two forces, driving forces taken together, are actually doing something. I mean, they're what's generating the solid lines. And when you remove those two driving forces, you get these dashed lines. And in particular, no change between pre and post 1990.
Kei-Mu,
So
but
yes.
a question on that. Sorry, but I guess you're not re-estimating the model in the counterfactual, right? You're just shutting down those.
Correct.
I guess if you were to re-estimate the model, then productivity differences would absorb some of the differences that trade costs are absorbing in the model with trade, and therefore you would be able to get a better hump with only productivity and no trade costs.
And my guess is that you would be right if we re-estimated the model. Then of course the parameters would be set in a way that would make the fit a little bit better. So I think that's right. It's just that keep in mind in this scenario, we only have aggregate productivity growth. There's no sector bias here. So I don't think it would look, if we re-estimated, I don't think it would look that different. I mean, I guess one way in which it could look different is maybe the model would put even more weight on the non-homothetic CES parameters. You know, yeah, so. Okay, then, so the second scenario, the autarky scenario, is where we shut down trade integration and only have the sector bias productivity growth. So there's two things you notice here. First of all, you see with the, again, with the dark and not so dark dashed lines, you can see a pretty strong hump pattern. And more importantly, you see that the hump declines from pre-1990 to post-1990. And the decline is roughly half of what it is in the full model with both driving forces. So in other words, the takeaway from this picture is that sector bias productivity growth alone can get you half of the full model's decline in the peak of the hump. So based on that, to the extent the model is linear, then you would think the trade integration would get you the other half. This is scenario C, where we have the constant relative productivity, so there's no sector biased productivity growth. So we only have the trade integration. And actually what you see here is while you get a hump pattern, you see virtually no change from pre-1990 to post-1990. If anything, it goes the other way a little bit, where post-1990 has a little bit higher hump than pre-1990. So trade integration alone is not accounting for deindustrialization. So, so let me show these results again, but now in the form of a table so we can get things to be a little more precise, and then I'm going to pursue like what's going on here in a couple more slides. So this table basically focuses just on the middle column of pictures from the previous slide, just the manufacturing value added share, and it kind of repeats what I was saying earlier. In the baseline model, we have this decline of 2.2 percentage points. The autarky scenario in the third column, which is the one with the sector bias productivity growth, you get half of that decline. But then in the constant relative productivity scenario, where you have just trade integration, you actually get it going in the wrong direction. And then if you add these two, the two columns on the right, you know, you add them, you get a number like negative 0.009, which is less than half of the baseline. So clearly there are some interaction effects going on. And the interaction of the trade integration and the sector bias productivity growth is accounting actually for the other half of the total baseline decline. So now I want to show a couple slides that talk about this interaction effect. And the first is, I'm just going to kind of go back to an implication of the model on spending shares. With the left-hand side, it's a slightly different spending share. Before I showed the spending share relative to aggregate spending. Now we have manufacturing spending relative to services spending, and this is on consumption goods. And the blue is kind of the relative price term, and the red is the income term. And we talked about the mechanisms earlier. But the point I want to make is the blue term is the more significant term, because as I showed earlier, you know, TFP is growing faster in manufacturing than in services. So that's going to make this relative price of manufacturing to services decline. And then in addition, trade costs are declining faster in manufacturing than in services. So that's going to further make this relative price further decline. And given these elasticities that we have, it's just going to mean that the blue term is just a bigger term magnitude-wise than the red term, you know, which is coming from the income effects. And let me push this relative price thing a little further, and that's on this chart. So these are for the three counterfactuals, the implications of the model for the relative price of manufacturing to services. Now, in each of these three pictures, you have this solid gray line that's common to all of them. That's in the baseline model. And then this the red shaded area and the black dashed line, that's the implications of each of the scenarios. And if you look starting from the left, the autarky constant relative productivity scenario, which is where we shut down both forces, or both forces are not operating, you see the implications for relative prices are almost constant. So obvious, and it's sort of to be expected with these income effects, there is going to be some relative price action, but obviously it's not much at all. And then you can see with the autarky scenario, which is where you just have sector bias productivity growth, that's causing a lot of relative price decline in manufacturing to services. So, and again, it's coming from the fact that there's higher productivity growth in manufacturing relative to services. And then finally, in the right scenario, constant relative productivity growth, where you have trade integration, you know, as I mentioned, trade costs are declining more in manufacturing than in services. So that's contributing a little bit to the decline in the relative price of manufactured goods, but not as much as the sector biased productivity growth. So what's driving then this interaction effect? Basically, the punchline is right here. So as I mentioned before, trade openness alone does very little for deindustrialization. But when you have trade openness happening at the same time as you have all these countries with rapid manufacturing productivity growth, basically what's going on is for each country, their contact with countries having high productivity growth in manufacturing, that's increasing over time. And then through this trade channel, that's going to spill over to lower prices of manufactured goods in each country. So this openness by itself isn't doing it, but in conjunction with the sector bias productivity growth, it's sort of amplifying the effect of sector bias productivity growth in terms of causing this deindustrialization over time through this relative prices. So this is one of our main punchlines, that the sector bias productivity growth on its own can account for half of the deindustrialization pre to post 1990, and then trade integration alone doesn't do anything, but trade integration in conjunction with the sector bias productivity growth through increasing, you know, the weight on these other countries that have the high productivity growth, that's going to lead to this deindustrialization between pre and post 1990. So now let me turn to industry polarization, and then I'll wrap up.
Okay,
so
yeah, just one curiosity.
Yes.
Spillovers is also working through the fact that now it's easy to import technologies, so to adapt technologies from advanced countries that have experienced that information before to I don't know, developing countries that are, so they can import the technology in manufacturing. And
yeah, so that's another way to look at it. So the fundamental TFPs, you know, they're changing through this, you know, through this sector bias productivity growth. That's regarding these fundamental TFPs. But then the solo residuals, you know, if you will, they're also affected by the trade, as I think what you're implying.
Yes.
And then it's like these solo residuals that are affecting these relative prices. So, okay, yeah. So let me show this industry polarization results, and then I'll wrap up. And you'll see here, there's also a heavy interaction effect. And here, again, we're just focusing on the manufacturing sector. And the data is kind of in the leftmost column. So this repeats a table that I showed earlier, where you see this, whether you look at the raw data or the residuals from the regression, you just see this increase in the dispersion of the manufacturing value-added shares from pre to post 1990. And then baseline is our baseline model. And you can see, if anything, the model explains more than 100% of the change in the data. In some sense, the model's a little too successful. And then to understand what's going on, then we have the three counterfactuals, and I want to start by pointing your attention to the counterfactual on the far right, the constant relative productivity counterfactual. So this is just trade integration. That's the only thing that's happening. And you can see that it implies a big increase in the dispersion of these manufacturing value-added shares, both in the raw data and the residuals from the regression, the conditional variances. In fact, it not only explains more than in the data, it explains more than in the baseline model, like by a factor of 2 or 3. And so first of all, what's going on with the trade integration? Well, trade integration, of course, is going to facilitate specialization. Some countries are going to specialize in manufacturing and other countries are going to get out of manufacturing. So of course, that's going to lead to an increase in dispersion in the manufacturing value-added shares. And as you can see from the model, it actually implies too much of an increase in the dispersion through this specialization effect. Then let me mention this autarky scenario, which is we have no trade integration and we only have the sector bias productivity growth. And you can see that this doesn't do much for the dispersion in manufacturing value-added shares. So, so basically what's going on is this sector-biased productivity growth alone, it's fairly balanced across countries. So it's just on net not leading to a big change in this, between pre and post 1990 in the dispersion of these value-added shares. But again, if you add the autarky and the constant relative productivity scenarios, you're going to get numbers that are vastly different from the baseline. So that again suggests that there's this big interaction effect going on between trade integration and sector bias productivity growth. And there is, except this time it's going a little bit in reverse in the sense that the sector bias productivity growth in conjunction with the trade integration is actually partially offsetting the effect of trade integration alone. And so what's going on here is, and this relates to a paper that Jing has with Andrei Levchenko. They document that manufacturing comparative advantage over time has diminished, across countries. So in the years since post-World War II, of course we've had trade integration, but if we look at the fundamental TFPs, the dispersion in those has diminished over time. So basically the sector bias productivity growth in some sense is going against the forces of specialization from trade integration. And this is why the baseline results, are smaller than what's implied by trade integration alone, plus the sector bias productivity growth alone. Okay, so now I'm just going to wrap up. Oh, there's one more chart and then I'll wrap up. We do this, this is more of an accounting decomposition from our model. And again, looking at, this is focusing on the deindustrialization. And here, instead of looking at value-added shares, we're looking at final demand or spending shares, to see which sector or can account for the main deindustrialization. And kind of the upshot of this table is it's mainly coming from sectoral consumption shares. There are what's driving the change in the manufacturing value added. Not so much investment shares or the aggregate investment rate or input-output linkages. So the action is coming through consumption. Now let me wrap up. And so we started out by showing these two facts. Deindustrialization, I think we just embellished or added to the original systematic evidence presented by Roderick. And then we have this, we think, new fact on industry polarization. And then, we build this model to try to explain these facts. And then our model, we just have these two, we focus on these two driving forces, sector bias productivity growth and sectoral trade integration. And then we do a series of counterfactuals that allow us to kind of conclude or develop little stories for the deindustrialization and the industry polarization. And our main deindustrialization story is it's coming from the productivity growth, the sector biased productivity growth, which is lowering the manufacturing relative prices. And then because all those substitution elasticities are less than 1, you're going to have less spending on manufactured goods. So the implication of that at the global level is that there's just a smaller market for manufactured goods today compared to, say, 3 decades ago. So that's going to limit how big a manufacturing sector, a late industrializer, can get, just because the global market share is smaller. And related to that, you know, a country that opens to trade now, just because of all of the past productivity improvements in manufacturing and the declines in the trade costs, a country that opens up now is facing a relatively low price of manufactured goods to services goods compared to before. So just the attractiveness of manufacturing, and now I'm speaking a little loosely here, but the attractiveness of manufacturing compared to, say, going into services is less than before. So this is all adds up to why this manufacturing peak is lower now than before. And then in terms of industry polarization, it's basically trade integration, which is just a very intuitive story leading to more specialization. Now in our framework, that kind of over-explains things, but what sort of brings it back to the data is the fact that there's also this sector bias productivity growth, which in conjunction with the trade integration is a partial offset. And that's coming about because countries without such a big comparative advantage in manufacturing are becoming more productive in manufacturing. And then all else equal, that diminishes the forces for specialization. So that's it. You know, thank you for your questions and your attention. And I and Jing and Mike were happy to take any additional questions.
Yeah, a couple of questions. What's happening with the service, the polarization or depolarization, the service in your model? Is because you show us at the beginning that the big change was there in some sense, that there was a depolarization in the service sector, no, in the data.
Right. In the raw data, it declined. Let me just check what happened in the okay, in the raw data and the conditional the residuals, the variance data declined. Yeah.
And this big, so it could be interesting to see whether what's going on in your model with that.
Yeah, we did that. Let me just see if we have it. I don't have it in the slides, but we have it in the paper.
Okay. And you get the same, a good match also?
For the baseline model, it does match. We do get a decline in both the unconditional variance and the conditional variance for services. So the qualitative pattern matches in the baseline model. So for agriculture, you know, agriculture, you saw the trade cost came down a lot. So in agriculture, the model implies at least let me just say that in agriculture, the model doesn't do as well. So I'll leave it at that. So services, it does fine, not as well as in agriculture.
Okay. And the other question is, why don't you, because there is this issue about the productivity and trade costs, why don't you try to put a little more structure in trade costs in terms that there is much more data on that, in terms that, okay, it could be the case that trade costs fall for all countries, okay, and then that is falling more or less the same way in for each type of goods. So there is more pattern, then you can use maybe a structure in terms of, okay, the trade costs will change at the sector level, plus an effect at the country level. So to have a little more structure to, especially for your last story about the complementarity or not of the shocks, because otherwise it could be a little.
I mean, we had structure in the sense that we allow for, you know, the way we calibrated it, we have it vary across sectors, countries, and time. But I think what you're asking is, why don't we do a counterfactual, sort of like the constant relative productivity scenario, where we have trade costs declining, but at the same rate across all countries, something like that. So there's no sector bias in the trade integration. We could definitely do that.
Have to try to look at that. Okay. So the change in the trade costs is at the sector level and country level. There is no interaction. There is no interaction sector country level. I think
it is sector country time. So in some sense, there is interaction on all three.
Yeah, but this is my point. Why, in some sense, maybe in the reality, you think that there could be a change in the trade cost of all manufacturing, more or less, and maybe it's different across countries, but in a little more structure in terms of saying that the trade cost is the sum of the change at the country level plus the change at the sector level. Because otherwise,
I see. We could write.
Because especially for your last story about the complementarities or the interaction effect, because in some sense you believe that trade costs are more correlated across countries and sectors than to. In some sense, it's hard to really, when you see the trade costs in manufacturing is falling for all countries more or less at the same rate.
Right. So we could do other counterfactuals where we have, like, the manufacturing trade costs decline at the same rate across countries. I mean, right now they're declining at their country-specific rate, so we could have them decline at the same rate across countries. Or we could do, as I said earlier, where the trade costs all decline at the same rate across all sectors. So, but maintaining the same variation across countries. So the different cuts we can do.
But I think will be more important in the first step, in the estimation step, because in some sense there you will be, because now you are an interaction term that's a little by contraction between trade costs and productivity shocks, because they can move completely to offset each other, that there is some problems for the fit of the data.
I see. I think you're saying that we allowed ourselves too many degrees of freedom in calibrating the trade costs. You want us to do a more restricted way of backing out the trade costs.
And I believe that
specific term, sector-specific term. I see.
And a country's term, because I think it's more realistic in some sense that usually many countries use the same type of transportation for the same type of goods, so it would be more realistic that, and I believe it will help you more, especially for the last story, whether there is complementarities or not in the between trade and productivity shocks, to explain your story.
Okay, great. Thank you for the suggestion.
Kei-Mu, can I ask you a brief question?
Yes.
Have you thought about like more welfare analysis or more normative analysis on sort of this discussion about deindustrialization? I guess the model doesn't have anything about deindustrialization being bad in some sense, whereas all the debate coming from Roderick's paper is about thinking of, how bad this deindustrialization is. So I'm wondering whether you have thought about allowing for something like this in the model to kind of make statements about, how bad these different counterfactuals are in terms of, changing the deindustrialization patterns. And how that affects. I guess here you only have like terms of trade effects. So maybe that's the only thing that would create some scope for policy, but I don't know whether you have thought more about technological spillovers or something else.
Yeah, no, as you said, Federico, our framework is this perfect competition framework, so there's no room for spillovers, and as you also said, if we had tariffs, there would be room for some terms of trade effects. But yeah, we would have to change the nature of the model to start to get at some of the Roderick policy implications. So Roderick, his framework, he believes in these Murphy, Vishny, Schleifer you know, this
Exactly.
multiple equilibria thing where if all the industries get together and make that big fixed cost investment, then you're going to have this big productivity boom. But if they don't do it, then you don't have that. And obviously, we don't have that in our setting. So, so we would have to change our setting, I think, substantially to be able to get at that policy question. But we thought as a first thing, you know, we just wanted to do this positive analysis, like what's explaining this stuff.